Hello and welcome. It's another homework help video. This is for chapter 12. We're getting close. We're almost there. Chapter 12 homework help video. All right, what do we got here? We got some AD curves. You see down here, we have real output quantity in billions per year. So they're just looking at our full economy, okay? And this is the price level, average price level for things, okay? So one thing you can notice, okay, as we go through here, as we increase what we're making, okay, what do you notice is happening? Okay, if I go from AD1 to AD2, what happens? Well, we increase in output. Let me get this a bit smaller. Our output increases. In addition, our prices increase, okay? So whenever we stimulate demand in the economy, whether it be through the government or people in general, we are able to stimulate demand as a whole in the macro economy, we're going to see an increase in output and an increase in prices, okay? And oftentimes we'll do this to help shore up what they call a GDP gap as far as employment, meaning there's a lot of people who aren't employed. If we can increase demand, then all of a sudden we're going to be producing more things. In order to produce those things, we have to employ people. All right, so that's the idea behind all of this. So let's go ahead and look down here, see what we have. All right, the GDP gap when the demand curve is at 81. So right now they're telling us, suppose the economy is at full employment at 82. So this is full employment, 82. Okay, the GDP gap when the demand curve is at 81. Okay, so they're coming over here. We go to 81. We're only producing 8 million as an economy. At 82, we were producing 11 million. Okay, so right here in the middle. So this is where they are producing at that point. This is where we would produce at full employment. So we're looking at about 8 to 11. So we're looking at 3 million. Or, sorry, 3 billion. That's the way they have it set up in this one. GDP gap and the demand curve is at 83. Now this is interesting. You can go past full employment. I mean, you could do things crazy. You have a war going on. There's things that you can do to push things past full employment, and people are working past 40 hours, and things could be crazy in the country, okay? It doesn't make sense. It's not a normal scenario you would ever see. But if you want to know what the gap would be, that's past full employment because of the way they got things going. Basically, look here, we got 15, okay? Here we're at 11. Go and highlight this. I think the solution's a bit wrong on this one, so this is what they're really looking at. There's 11. Here is 15. Therefore, the gap between these two would be 4. 4 billion. Yeah. So the solution on this might be wrong in the book. I think I've contacted them once. I'll probably contact them again because they don't know what they're doing sometimes, but that's what they're doing. And also, this is a theoretically, if you could put this past full employment, which if you do, if you ever go past full employment, you're going to get crazy hyper inflation as far as prices go. Like, it's not good for your economy. You'd only do it probably at like wartime, where basically everyone is working and they're working more than 40 hours, and it's just crazy amounts of work going on. Or people are in the military. It's just something you're not going to typically see. So, all right, that should solve all that. Let's check and see if we're right. And we are right. So if I'm ever the government, let's say I started out at 81 and I wanted to increase employment, well then I'd probably have to spend $3 billion worth, and not necessarily what I put in, but overall the economy would have to get to $3 billion more being demanded running through cycles of money. So let's take a look and see what these cycles of money would look like. Oh, first they're going to have us do some basics, okay? Marginal propensity to consume. There's two different things that are out there. you have what's called MPS. That's how much you save of each dollar, okay? So if I gave you $1, right here, $1, and say you always saved 80 cents of it. If you saved 80 cents, then by default, what are you spending? 20 cents. So that'd be your MPC. So MPC is going to be the inverse of your MPS. Okay? And so this person would be super thrifty. For every dollar that comes in, they save 80% of it, only spend 20%. This sounds like someone who's super rich and just getting richer and richer, and they only need to spend 20% because of how rich they are. Okay? That's what you'll typically see. People who are really high in society have a super high MPS because they constantly have money coming in and they just don't need to spend that much, and then it leads to them being even wealthier. MPC is typically super high among poor people just because you're trying to survive, and so every dollar you get in is typically going out. You're living paycheck to paycheck. So let's see what this says here. The marginal propensity to consume is, well, marginal propensity to save is 0.20, so let's do this in a different one. We'll clear all this. So MPS is 0.20. This equals MPS. MPS is 0.20. All right, what's MPC going to be? So remember, MPC is what's left. So if I'm saving 20% of what I get, so let's say I get $1, and I save 20% of this dollar, I'm going to spend how much of it? Well, by default, I'm going to spend 80. If I'm saving 20, then it gives me 80 to spend. So then my MPC would be 80. The way you can double check this, always adds up to 1. Okay? MPS plus MPC should be 1. Okay? They're inverses of each other in that they add up to 1 and as far as the inverse goes. So, but so let's say I had an MPS of 0.3. Let's change this a bit. 0.3. Oh. By default, what's my MPC going to be? Well, in order to add up to 1, it's going to be 0.7. There we go. So there's another sample one you could do, and you can just play around with it, but it's always going to add up to 1, and they're always going to be proportional to each other because of adding up to 1. All right, so let's put that in there. MPC, we'll go 0.8. The multiplier, ooh. The multiplier is how much this would go around into society, okay? So if this money is going around and around in society, and every time someone gets $1, and this is in general, this is everybody had the same MPS, and then they put 80 cents into the economy, how much total will go into the economy of this dollar, okay? Because it's going to keep kicking around, but every time it kicks around, people are keeping a part of it until it's gone. Well, the easiest way to do this is get your MPS, which in this case is 0.2, and all you do is divide 1 by it. Okay, so if I go over here to the handy dandy calculator, pop this up, I go 1 divided by MPS, which is 0.2, equals 5. So what this means, for every dollar I put into the economy, if the economy as a whole has an MPS of 0.20 or 20%, that means $5 worth will go around in the cycles. Okay, as it gets kicked around in the economy over and over and people exchange it, it'll move around 5 times. Okay, so let's go ahead, put in a 5 over here. That's going to be our multiplier. That's how much it's going to kick around into the cycle. I put $1 in. It's going to have an effect of $5. That's how much it's going to keep going around in the cycle. Check my work. All green. Good to go. Good to go. Let's go to the next one. Ooh, here we go. Here's a big one. We got a fancy graph here. We got a government spending $100 billion. They're trying to do something with that. In the figure, a cycle is originated by a change in spending in the product market. Assume that MPC is 80, okay? So let's go ahead and get out our thing. So if MPC is 80, by default, what is MPS? Remember, it has to add up to 1. What's MPS going to be? How much are they saving? If I'm spending 80, I'm saving 20. Okay? This adds up to 1. There we go. We got 1 right there. All right. How much spending would occur in the third cycle? So let's go ahead and start identifying cycles, shall we? Do blue. Cycle 1. Government spends 100 billion. Cycle 2. People get that 100 billion because it goes in through here, through into the firms, and then households get that 100 billion. And how much are they going to spend of it? They're going to spend 80%, right? So it's 80% of 100. 80 billion. Okay. Third cycle. They're going to get 80 billion. 80 billion is how much they're getting. How much of this 80 billion will they spend? Okay, so right here, this is what they're spending each cycle, okay? Spend. Over here, this is what they get. Okay, this is what they get. So, what are we going to do? Well, they get 80 billion. They're going to spend 80% of 80 billion. So let's get out the handy dandy calculator. We go 80 times 0.8 equals 64 billion. That sounds right. And it should be right. 64 billion. And if you wanted, you could actually go over here and you could keep a running total, okay? You could keep a running total of all of this. So far we put in an initial 100 billion and we have created an extra 80 billion so far spent, an extra 64 billion, and you could keep a running total over here, okay? It does that on a future problem, so I won't worry about doing it for this one. Or it should do it on a future problem. Let's see. Let's go for... Okay, so now we have 64 billion. Actually, we might have to do a total. Let me see about this one. Oh yeah, this one I think we do have to do a total, yeah. Alright. 64 billion. And how much do we spend of 64? Well, we go over here. Press equals one more time. It'd be 51.2. 51.2 billion. In our fifth cycle, we get 51.2 and we spend, and we end up spending how much of it? Just press the equals over here again. It keeps doing it. 40.96. Remember, each time we're spending 80%. So then we go over here. 40.96 billion. Alright, let's see if this is enough to start answering stuff. How much spending would occur in the third cycle? Well, we end up with 80 billion and they spend how much? 64 billion. So that's pretty straightforward. 64. How many spending cycles would occur before consumer spending is increased by 200 billion? Remember, not total spending. This was what the government spent. They want to know how much consumers are spending. This is where the consumers are spending. So we got to add this up and see at what point we get to 200 billion, okay? So let's go ahead and take a look at this. Go over here. So we got 40.96. We need to clear this. Let's go 80 plus 64. 144 plus 51.2. So we're at 195. But it says here, how many cycles would occur before consumer spending is increased by 200 billion? We're still not to the 200 billion mark yet. So we plus 40.96. All right, so then we get to 236, and then we finally cross the threshold, so that would be in the 5th cycle. All right. And let's see what we got. See what you got. Check my work. All good. All right, all green. Let's move on, shall we? We're already on question 4. You guys are cruising. We're getting to the end. There's light at the end of the tunnel, I promise. We're almost done. Suppose the government increases education spending by 20 billion. Okay, so remember, this is the government. It's a lot different because if I give it to people, they're going to save a portion of it before it even goes out into the economy. But if the government spends it, it goes straight out into the economy as 20 billion. So we start off with that 20 billion. Okay, we don't have to take anything out. So we get 20 billion. There we go. That's a sad looking billion. Sad it had rough times. Now, if the marginal propensity to consume is 0.8, by how much will total spending increase? Okay. So if 0.8 is MPC, what is MPS going to be? It's going to be 0.20 because it's going to be relational to it to add up to 1, right? MPS. If I save 80 cents, by default, I'm keeping the other 20 cents of a dollar. This is MPS. This is my savings. Okay? And the simple format is we just got to get a multiplier for it. 1 divided by 0.20. So in other words, 1 divided by MPS is your super quick shortcut to find out this multiplier. If we do this, we go Alt-Tab, go over here, we take a 1, divide it by 0.2 equals 5. All right, there are little equals over here, equals 5. So 5 times what? 20 billion. That's how much it's going to kick around in the marketplace. So it should be 100 billion. 100 billion is what we should get because it's going to be 5 times 20 billion. So you take this multiplier here, times it by our original, which is the 20 billion. Should equal 100 billion. Check my work. Let's see what happens. Yep. That's it. That's all you do. Now, if it was a tax cut though, we wouldn't be able to start with the 20 billion. If this was a tax cut, 20 billion doesn't work out. Because when I give the people the 20 billion, the MPC and MPS starts immediately, and so I'd have to apply that discount to it. And so if it was a tax cut of 20 billion and we had this MPS all going on, I'd have to do my MPS first to this. So I'd be 20 billion, meaning they'd only spend 16 billion. So all I'd do would be 5 times 16 billion instead of 20 billion if it was a tax cut, because you have to reduce this number first because you're not going straight into the cycle. You're giving it to people, and then people are going to save a portion and then put it into the cycle, if that makes sense. Because if it goes straight into the cycle, the government's going to spend every dollar it gets in the budget. But if the government's giving you the money, you're going to hold back a bit. And by this account, that's how much you would be holding back. And so we'd have to adjust this number by that. So 20 would be adjusted by 80%. So it'd go down to 16 because 80% of 20 is 16 billion. That's what you would do. All right, let's move on. Clear all that. Boxes. I see lots of boxes. Let's see what we got to do. The multiplier process depicted in the following table is based on an MPC of 0.75. That's good to know. So this is the MPC we're using, 0.75. Recompute the first 4 cycles using an MPC of 0.80. So we're using the 0.80, and they use the 0.75 to do all of this. Okay, that's the work they did. They want us to redo it with 0.80 over here in these boxes. So we can use this to kind of check and see if we're doing it right. Does that make sense? This is a pretty easy guided one, for the most part. So if we spend 100 billion, okay, what's the cumulative increase in spending? Well, for that year it's going to be 100 billion for including the initial amount. Okay, then it gets over to here. And see how here they're showing it get reduced down to 0.75? Well, that's because of why? That's because they're saving 25% of it. They're only spending 75%. Over here, with an MPC of 0.80, they're going to spend a lot more of it. So they're going to spend 80 of it and save 20 of it. So they're spending 80. And the way I know this is all you do is you take 100 over here. 100 times by, what's our MPC? 0.8, and that's going to equal 80. Here's a 0.8 there, there's a point. So 100 times 0.8 equals 80. What do we have here? 80, right there we have 80. Then all you do is keep adding it up. So 100 plus 80 is 180. Okay, now we're on to the third thing. So what's 80 times 80? Or, I'm sorry, 0.8. I shouldn't say 80 times 80. What's 80 times 0.8? Quickly do that over here with a calculator. 80 times 0.8. 64 is our new number here. 64. And then 180 plus 64. 180 plus 64, 244. So remember, on this right side, that's just our running total. So every time, we're just adding this onto it. So we take 80 and 100 equals 180. 180 plus 64 equals 244. This is just a running total over here of what's going on. All right, on the fourth. All right, well, let's go ahead and let's clear all this stuff off so it's not too messy. Let's bring up the calculator again. So 64 times 0.8 equals 500 or 51.2, and we're going to add that 51.2. Let's go ahead and add that to this over here. Plus 244. Our new running total is 295.2. 295.2. Let's check and see if we did everything right so far. It's a good time to check your work. No penalty, check it early. It lets you. Sometimes it might be angry and bitter. All right, there we go. Finally got it to go. Sometimes you have to click and hold. Sometimes that helps. All green. All right, we're doing it right. Now remember, if you don't know what you're doing, compare it to how they did the 0.75. They literally did it for you over here with 0.75. Here's changing it to 0.80. And one thing to notice with 0.80, are we spending more with MPC? Therefore, we're getting bigger numbers over here, right? We're getting bigger numbers over here cumulatively. Okay, and it's kicking around a bit more in the system. Given that the MPC is higher, How much more consumption occurs in the first 4 cycles when MPC is 0.8 as compared to 0.75? So we go down here, our spending cycles right here. They're saying this one right here. And our 0.75, and they're looking at cumulative, right? First 4 cycles, MPC is compared to this. How much more consumption? All right, this is our cumulative spending right here. So these are the 2 numbers we're comparing. So all we do is take 295.2 and minus that. So let's bring up our calculator, shall we? 295.2 minus 273.44 equals 21.76 billion. All right, that's 21.76 billion. Just put it in here. 21.76 billion. All right. Hopefully that works out. Looks good there. Okay. What is the value of the multiplier? Okay, so let's go ahead and look at these again. Clear all this out. If my MPC is 0.75, what should my MPS be? MPS will be 0.25 because both of these numbers have to equal what? 1. They all have to add up to 1. So 0.75 and 0.25 have to become 1. Vice versa, if I come over here, do our second one, if I have an MPC of 0.8, what's the MPS going to be? Remember, it has to add up to 1. It's going to be 0.2. And both of those together equal 1. However, we need to find the multiplier. Remember, the easy multiplier is 1 divided by MPS. This is the easiest multiplier formula out there. Let's do this. So on the first one, our MPS is what? On 0.75, it's going to be 0.25. Bring up our calculator. 1 divided by 0.25 equals 4. So we got 4 there. So remember, we used this number right here. So it was 1 divided by 0.25. Second one, I can just do this in my head. It's pretty simple. So we're going to have 1 divided by 0.20. That's going to equal 5. And we notice we used that MPS right there. And this is your master formula to find that multiplier. Come over here, put a 5 in there. Let's check it. Did we do it right? Looking good. Did all good there. And that was question 5. That's it. Okay, you guys made it. It's good having you guys in class. Keep working hard. Do everything you need to do. All right? Keep up the good work. If there's anything you need, let me know. Let me clear off this. Okay, you guys all take care.